In this video, we're going to be making an arced line like you might see in Baldur's Gate 3, something like that, where you've got, just that nice curved line. No matter where you're aiming, it maintains that same shape. So if you're targeting an enemy or an object or something like that. So let's go right to it. Jumping straight into Unity, we're going to create a quad, and we'll name this ground. And let's rotate that 90 degrees on the x-axis and size it up to something like 50, just something really big. And then let's go create a folder called materials. And inside there, we will create a new material. We'll call this ground, and we'll just make it black. Next, we'll create another 3D object. This one will be a capsule. We'll call it player. And let's move it up 1 on the Y so that it's not clipping through the ground there. And we can just zero out this position otherwise. Now let's create another material for the player, which we'll call blue, and we will make it blue. And we'll just drag and drop that onto our player capsule. Then we can duplicate the player, and we'll call this one enemy. Drag that over a little bit. Duplicate the blue material, call it red, and change the color to red. And we'll drag and drop this one onto our little enemy capsule here. Next, let's create another folder for scripts, and we'll make a new monobehavior script in here called arcline. And this is going to be the only script we use in this video. Then we'll click on our player, and we will add a line renderer component. And we'll add our arcline script as well. Then open up the line renderer and go down to materials and just make sure it's not empty here like mine is. We'll just use the default line. And that'll be it for now. We'll come back to that later. Open up our arcline script and let's delete our start and update method. Now, just to do a quick overview of what this script is going to be and how it's going to work, we need a start point and an end point. So where our line begins, where it's going to end. We're going to use the line renderer that we attached to the game object, and that's what's going to actually draw the line for us. We want to establish what the arc's height will be, and I want to make all of these things that we can tweak in the editor, so it's just really easy to adjust it to make it look exactly how we want. We'll have something called height distribution, which is going to control where the peak of our arc happens, kind of how intense or mellow the arc is. We'll have something called forward push, which is going to give it some of an launched outward feel rather than just a pure hump. And then we'll have a smooth endpoint and smooth speed to keep the arc from being like jittery if the endpoint is moving around fast. The smoothing isn't necessarily a requirement, but I like to smooth things as often as possible, and it's good practice. We're going to be using something called use startup direction, which isn't going to be really relevant in this particular video, but maybe if we come back to it, it's something we might want. The idea with it is that, suppose you were aiming at a target from your character's hand, like they're pulling back a bowstring. You might want the arc to be rising relative to where their hands are positioned. That's what that bool will be for. We'll also just have the ability to make it always rise with world space. And in this video, that's all we're going to be doing. So with that introduction out of the way, let's dive into the actual code here. I like to keep things nice and organized, so we'll start by making a header, which we'll call references. I'm going to make several serialized fields. The first one will be a transform. This will be for our start point. And then we'll do the exact same thing, make another serialized field transform for the end point. Then we will make another one, and this will be for our line renderer, which we can just call line renderer. Let's go down a couple lines, make another header. This one will be called arc shape. So these are going to be all the variables that determine what our arc actually looks like. We'll set this serialized field to a minimum of 2. That is just to prevent you from accidentally making your segment count smaller than will function. Then we'll make another serialized field. This will be a float for our arc height. So how tall do we want this arc to be? We'll make another serialized field, and this is the most important one, arguably. This is an animation curve, and we'll call this our height distribution. And this is going to equal a new animation curve with a new keyframe. We're going to have 3 keyframes here. The first one, our starting point, the beginning of our arc will be at 0. That's the position it's going to be at. Then we'll have at the halfway point, 0.5, we'll put it at its max height, in this case 1. And then at the end, which is 1, we'll put it back at a starting point, which is 0. If that is not making sense to you looking at it, it'll be really clear when we get back in the editor and you see what it looks like. Let's make another header. This one will be called direction control. And this is where we're going to do the things we were talking about before with our, starting up direction versus world up. So we'll create our bool, use start up direction, and we'll just set that to true. Again, this one doesn't really matter right now for this video, but it's something that gives you the idea for a frame of reference if you wanted to expand on this. Then we'll make another vector 3 called world up direction and set that to be vector3.up. We'll do another serialized float. This one will be forward push, and we'll initialize that at 0.5. Now let's make one more header. This will be for smoothing. We'll make a serialized field, bool, smooth endpoint equals true. Another serialized field, this one will be a float. This will be the smoothing speed, and we'll just set that to 10. And then we'll have one private vector 3, which we call smoothed end position. Now in awake, we're going to have 2 methods. One called initialize smoothed position, and one that's update arc. And then we'll just do the exact same thing in the onEnable method. This is a bit redundant, but it's a potentially bad habit of mine. If I have it happening on awake, I want to make sure that if I ever turn this script off and back on, that it does it again on enable. And then I don't know why I put this method in here. It's not necessary. We're already putting the line renderer component in our serialized field, so you can just ignore that reset. And then our update method, we will put our update arc method. Next, we'll actually create some of these methods. Private void, initialize smoothed position. If endpoint does not equal null, then smoothed end position equals endpoint dot position. That's it for that one. Private void update arc. This is going to be where the meat of what we're doing is happening. If start point equals null, or our endpoint equals null, or our line renderer equals null, we want to return. We don't want to do this over and over again if any of these things are not actually going to be working properly. Next, we'll put vector 3 start point dot position. We'll make another vector 3 target end, which will equal endpoint dot position. Then we'll say if our smooth endpoint exists, float t equals application dot is playing question mark 1f minus mathf dot exp, and then minus smooth speed times time dot delta time colon 1f. Smoothed end position equals vector3 dot lerp smoothed end position target end t. Now, if you're looking at this and it seems like just complete gibberish, for the sake of simplicity, I'm not going to deeply explain what's happening, but the simple explanation is we're making it so that this smoothing effect that happens is independent of frame rate. No matter what someone's frame rate is, this is going to be smooth to them. And we'll say vector3 end equals smoothed end position. Then line renderer dot position count equals our segment count. And we'll say vector3 up direction equals use start up direction question mark start point dot up dot normalized colon world up direction dot normalized. Basically, just depending on what we've set our bool to say, if we're using the startup direction or if we're not using it, based on the status of that bool, either use the start point dot up dot normalized or use the world up direction dot normalized. Then we'll do vector3 forward direction equals end minus start dot normalized. Then we're going to make a for loop. For int I equals 0 semicolon, I is less than segment count semicolon, I plus plus. Float t equals I divided by float segment count minus 1. And we'll do vector3 base position equals vector3 dot lerp. And now we have our start, end, and t. And we'll make another float. We'll call this height offset equals height distribution dot evaluate t times arc height. We'll make another float, and we'll call this forward offset, which we will have equal to height distribution dot evaluate height distribution dot evaluate t times forward push. And we will do another vector 3, call this curved position, equal to our base position plus our up direction times our height offset plus our forward direction times our forward offset. Then we'll say line renderer dot set position I curved position. And that should be it. Everything should be working. So let's pop back over into Unity and we will go to our player, and you can see we have all of these serialized fields now that we can drag our references into. So our start point is going to be player, end point is going to be our enemy. The line renderer will drag into the line renderer, and let's hit play and see what this looks like. Okay, there you have it. We have a line being drawn between our player and our enemy. We move the enemy around, and the line follows him. I hate how that looks right now, so let's go into the line renderer, our animation curve here, and just pick a different one. Edit this key to be 0. I'm going to drag this up so that it's more of just a plain looking arc here. That's good enough for now. And let's bring the width down by like half. It's way too thick right now for my taste, and let's hit play and see how that looks. Much better. So we can move the enemy around, the line is following them. This arc could be higher for my taste. Let's change that from 2 to say, whoa, whoops. Let's put that up to like 5. That looks pretty good. And now when we drag the enemy around, you'll see it maintains that shape no matter where he is. We can move him up, we can move him down, all over the place. And we have this nice curved line aiming right at it. Awesome. That is pretty cool. So yeah, there's a lot of things you could do with this to adjust it. You can play with the animation curve to make it look exactly how you want. You can play with the width of the line to make it a little more artsy looking. You can change the color. Coding-wise, there are tons of things you could tweak here and extend to make this work the way that you want. If you've got a system already in place where you can target an enemy, you know, this could be automated. You could get rid of the smoothing altogether. You could have the line disappear if you're not currently targeting an enemy, and then once you are, the line could appear. But the main point of this video was just to explain how to make a nice looking arced line in the first place. And there you have it, folks.